Alright, this is the second lesson of Unit A, Real Numbers, Exponents, and Scientific Notation. This lesson is going to cover powers of monomials. So the focus of this video is going to be the same as the previous one. Know and apply properties of integer exponents to generate equivalent numerical expressions. The difference of this lesson is the properties that it covers. In the previous lesson, we covered the product of product of exponents and quotient of exponent properties. This one is going to cover power of a power property and the subproperties power of a quotient and power of a product. So we're going to touch on it by looking at what a power of power looks like, as well as how do we simplify it, and as well as looking at a power of a product and a power of a quotient and how to simplify them. To start with, let's review from the previous one on how to simplify product of powers and quotient of powers. 2g to the second times 8g to the 6th, h to the 7th over h to the 4th, negative p times negative 9p to the 2nd, and 36w to the 10th over 6w to the 5th. Simplify these four problems. Pause the video if you need to. Once you're done solving them, then continue with the video. Alright, let's check your answers. For number 1, you should have gotten 16g to the 8th. Multiply the coefficients of 2 and 8, you get 16th. Then use the product of powers property when you do g to the 2nd times g to the 6th, and you get g to the 8th. Number 2 follows the quotient of powers property, where we would subtract the denominator's exponent from the numerator's exponent, and we would get h to the 3rd. On number 3, we're looking at it. There's no numbers in front of the first p, but we know there's an implied 1 there. The same with the fact that there's an implied 1 exponent on the p. So when we group these together, we would have negative 1 times negative 9, and then we would have p times p to the 2nd. Negative 1 times negative 9 gives us a positive 9. The implied 1 here plus 2 gives us 3. And then finally, for the fourth one, we would have 6w to the 5th. 36 over 6 gives us the 6. W to the 5th over, w to the 10th over w to the 5th power. Using the quotient of powers property, we would have w to the 5th. So a power of a power property. This is what it looks like. Essentially, we have an exponent expression being raised to another power. The key to this is that there is a expression inside parentheses and then an exponent outside of that as well. So how do we simplify it? Well, we could go about it one of two ways. The first way is we could rewrite the expression that we're given into the expanded form. So we have 4 to the 3rd to the 2nd power. We could expand that out because it's saying we have 4 to the 3rd times 4 to the 3rd. And then from there we would use the product of powers property and add the exponents. And we would get 4 to the 6th power. Or we could do it a more straightforward way, where we have 4 to the 3rd to the 2nd power, and what we're doing here is we would take the outside exponent and multiply it to the inside exponent. So 4 to the 3rd to the 2nd power, which would give us 4 to the 6th. Both ways give us the same answer. It's just one is an expanded form, one is just a quicker method. So when raising a power to another power, we multiply the exponents together. So let's look at the sub-properties that go with a power to a power property. The first one we have is a power of a product property. And what that means is that our expression inside the parentheses has more than just a number or a variable in there. There's a product of both a variable and a number going on. So to find the power of a product, we would find the power of each factors and then multiply. So let's look at this example. We have 3 to the second to the 5th power. Well, we would expand that out and list all the, then we would go through and list all the factors together. So we expand it out to 3a to the 2nd power, and we'd have it 5 times. And then we're going to group all the factors together. So all the 3's are going to be multiplied together, and then all the a to the seconds will be multiplied together. So we would have 3 to the 5th power because we have 5 3's, and then we'd have a to the second raised to the 5th power because we have 5a to the seconds. So the first one we just have an exponent expression. The second one we have a power of a power product, or I'm sorry, a power of a power property, which we just talked about. So from there, we can simply just jump right into it and do 2 times 5, which gives us 10, and then we could do 3 to the 5th power and gives us 243. So we have 243 times a to the 10th power, or simply stated 243 a to the 10th. So with a power of a product property, there's all this work right here you could do, and you can see all the work being done. I like to look at this property and think of a simpler way to look at it. And when I do, I think of distributive property, but more of along the lines of an exponent distributive property. Because if we're talking about distributive property, we know that if there was a number on the outside of a parentheses, we would multiply that back into the expression, and everything inside the parentheses would be multiplied by the coefficient on the outside. Here, what we're thinking is that we have the exponent on the outside, and it's going to be multiplied to all the expressions, or all the variables and coefficients inside the expression. Meaning that if we look at the 3, it has an exponent of 1 on it. Anytime we see a number or a variable that doesn't have an exponent on it, it's 1. It's an implied 1 because the exponents tell us how many times we see that number, while we only see it 1 time. So I would be taking the outside exponent and multiplying it by 1 on that 3. On a to the second, I'm multiplying the 5 to the 2. And it would give me 3 to the 5th a to the 10th power. That's why way I think about it with distributive property. If you don't like think of it that way and you like doing it this way up here, that's fine. I'm just thinking of a simpler way to try and help some people out that might need that little shortcut that helps them out. The same can be done for the power of a quotient property. You can work it out just like the other problem we did, or you can just jump right into it and find the shortcut method. With this example, I'm doing the shortcut method just to save a little time, but I want you to see here that we have 3a to the 5th over 4a to the 3rd raised to the 3rd power. So like I said, I just jumped right into it, and I did 3 to the 1st times 3, a to the 5th times 3. So I took that exponent here and brought it to this 3, as well as a to the 5th, as well as 4 to the 1 times 3, as well as the a to the 3. Oops, I made a mistake there. But that's supposed to read as a to the 3rd times 3. So this 3 on here would be brought down into the 4, as well as the a to the 3rd in this expression. And when we simplify that, we'd have 3 to the 3rd times a to the 15th over 4 to the third times a to the ninth. And then we could apply the quotient of powers property here, where I have a like base in the numerator and the denominator. I would subtract their exponents together to simplify it. You could put the exponents into standard form, or you could leave it as a exponent expression. Most cases, it's easier to leave it as a exponent expression because sometimes the numbers get so large, it's easier just to write the exponent instead of saying, oh yeah, it's 27 instead of 3 to the third. So let's give it a try. I've got about 5 questions I want you to try, and it's a mix of the product of the power of powers as well as the power of a product and a power of the quotient properties. So 5 questions, and I want you to try them all. We have 8 to the 4th to the 3rd power, k to the 7th to the 5th power, 2w to the 2nd over 5w raised to the 3rd power, negative 2m to the 7th power n to the 6th power raised to the 5th power, and then 3 to the 2nd raised to the 3rd raised to the 2nd. So try these 5 problems, pause it if you need to, and when you're done, restart the video and check for the answers. Alright, let's check those answers. So for the first problem, 8 to the 4th to the 3rd power. It's just the power of a power property. You're multiplying the exponents together, you get 8 to the 12th power. This is what I was referring to earlier, where it's easier to leave the expression in exponent form instead of trying to put it in standard form, because to put this in standard form, we would multiply 8 12 times together and we'd get a really large number, and it's easier to leave it in exponent form. Number 2, k to the 7th to the 5th power. We'd get k to the 35th power. 2w to the 2nd power over 5w raised to the 3rd power. With this here, I've got my final answer of 8w to the 3rd over 125. So this one here, I took the 3, distributed it to the exponent on the 2, the w to the 2nd, the 5, and the w. You can see that all right here. It gets multiplied together. I get 2 to the 3rd, w to the 6th, over 5 to the 3rd, w to the 3rd. I put 2 to the 3rd and 5 to the 3rd. I express that as standard form because these are relatively smaller numbers, and I figured, okay, let's just go ahead and put that into standard form. That way, all we're dealing with is w to the 6th over w to the 3rd, which then we'll use the quotient of powers property to subtract them to give us the 8w to the 3rd over 125. Number 4, we have negative 2m to the 7th power, 6 to the nth power, all of that raised to the 5th power. So all of that together, I mean, we have that negative 2 here in the front. That negative 2, that whole expression right there is negative 2. So the whole thing has to be raised to the 5th power. Not just the 2, but the negative as well. Because that's saying I have negative 2 times negative 2 times negative 2 times negative 2 times negative 2. I believe that's 5 I said. And then we have m to the 7th times 5 and n to the 6th times 5. So when we simplify that now, we have negative 2 to the 5th, m to the 35th, n to the 30th. And then you could also simplify that down and take the negative 2 to the 5th and write it in standard form, which would give us negative 32 m to the 35th, n to the 30th. Either answer would work for me. And then our last one, 3 to the 2nd, raised to the 3rd, raised to the 2nd. The thing about this one is you could have done it either way. It didn't matter if you worked from the inside and moved out or if you moved from the outside and moved in. But the power of a power property works here either way. Or I can raise 3 to the 2nd times 3 and gets me 6. And then multiply the 6 and the 2 together and it gives me 12. I will still get 3 to the 12th no matter which way you did it. It wasn't meant to be a trick. If I tricked you with it, I apologize, guys. I just want you to see that sometimes they will raise a power to a power and then raise it again to another power. Alright, so that concludes this lesson. If you have any questions, please don't hesitate to sign up on the help board. Maybe rewatch this video, take a little bit more notes on it, and then move on to the next activity. Alright, guys. Have fun.